This lab examines a special case of Newton's second law, constant velocity motion, or an object moving at the same speed without changing direction. Newton's second law states that the final velocity equals the initial velocity plus the net force on the system divided by the mass of that system times the change in time, and is given by this overall equation. A derivative of that law allows for the prediction of an object's position over time, stating that the final position equals the initial position plus the average velocity over a time interval times that time interval. Using this fundamental principle, I analyzed a glue stick that appeared to be moving at constant velocity in Tracker and created a model for that movement in Vital. The results show that the model data and the observed data were similar but did not match exactly. In order to observe Newton's second law, a glue stick that appeared to be moving at constant velocity was taped and examined in Tracker. The video was calibrated to the size of the glue stick, and the glue stick was weighed for its mass. The orientation of the axes was also decided upon based on the direction the object was moving. The x-axis is oriented to be parallel to the surface, with the positive direction facing the right. The y-axis was perpendicular to the surface, with the positive direction facing up. The z-axis was along the surface, with the positive direction coming out of the screen and the negative going in. The origin was placed at the starting position of the glue stick. The orientation of the axes does not change the outcome of the lab. It merely affects whether the graph is of positive or negative slope and where it begins. The magnitude of the lines would be otherwise identical. Then, the glue stick's position at every frame was obtained and recorded, as seen here. Using 2 points from the Tracker analysis, one where time was 0, and another while time was 0.111 seconds, the velocity was calculated. Velocity is the speed and direction of an object's movement and can be calculated by dividing the change in position over a time interval by that time interval, as given by this equation. The velocity was found to be 0.135 meters per second and was used as the initial velocity. This information was entered into Vital as code and was the basis for the model. Both equations from Newton's second law were coded into the program. In order for a constant velocity motion to occur, the net force on the system must be 0. This allows for initial velocity to equal final velocity. This special case is also referred to as Newton's first law, which states that an object in motion will remain in motion, or an object at rest will remain at rest until some force intervenes. To allow this, the F-net was set equal to 0. With all the necessary data entered into the code, the program could now generate a model. Using the data points generated from the model and from the Tracker analysis, a graph was generated showing both sets of data. As expected, the model is a straight line that is characteristic of constant velocity motion. The observed data, however, while resembling a straight line, is not. There are 2 points in the graph where the slope changes. However, the slope only changes in those 2 points and immediately recovers its previous slope. This suggests an error in the human side of the analysis and can be attributed to the poor video quality. Maintaining the exact center of mass of the object as it moved proved to be a challenge, and there is a high probability that the discrepancies were caused by my own error. However, at the end of the graph, one can observe a slight decrease in the slope, suggesting that the velocity is beginning to slow down. This would be possible if, at the end of the video, the object was not moving at constant velocity and was slowing down due to the force of friction. However, it could also be caused, and was most likely caused, by the movement of the glue stick in the negative z direction. The model only takes into account the movement along the x-axis, not the movement along the z-axis. If the object was analyzed for multidirectional movement, then there is a definite possibility that the model and the observed data could have matched. The backwards movement of the object also could have skewed the Tracker analysis because the video was filmed directly facing the glue stick. In conclusion, the motion of an object moving at constant velocity can be modeled by the application of Newton's second law. However, in my analysis of a glue stick's motion, there was discrepancies in the data due to human error in analysis and the movement of the object in the negative z direction, which was not taken into consideration.